Okay, welcome you all to the second session on Sunday's class, right? So we were at uh, so we were here. Okay, so we were discussing about how microbial enzymes can be a product of fermentation and how these can be very useful in different industries, and we've just seen examples of as how proteases can be used in washing powders, in purification of different products, and how carbohydrates they can be used in preparing simple sugar syrups, which are much sweeter and has a lot of uses, especially in preparing beverages and juices, particularly to sweeten different kind of products, right? Then there is immobilization of enzymes or whole cells by their attachment to inner polymeric supports allows easier recovery and reuse of the biocatalyst, right? So as we are going to discuss um, later on as well, we are going to discuss about how enzymes are produced, how bulk enzymes are produced, what is the flow, how do we bring about that possible. But we're also going to look into immobilization of enzymes as well. What immobilization of enzyme is, that enzyme, there's this thing, let's just suppose and imagine that you have an enzyme which is in a powdered form, and what do you do? There is this media, a liquid media, and you're simply dissolving that powdered foam inside. But this kind of an enzyme, which is a stable powdered form of enzyme, is not something which is immobilized. Immobilized means that there is this support system. There is this matrix which is inert meaning it's non-reactive. So you're using any kind of biomaterial which is inert in nature, which is not reacting with the substrates for the products or any other enzyme, but it is actually absorbing the enzyme and holding the enzyme. So what kind of effect does it have of an immobilized enzyme in any kind of fermentation process is that there is easy recovery, meaning once you add enzyme in any kind of fermentation media, then there is requirement of purification of that product, extraction of that product from the whole media source, right? So, in order to minimize that effect, especially for enzymes, particularly, that what do you do? That you put an enzyme on a kind of a support system. You can simply imagine that there is a sieve, and that sieve has a surface which has coated enzymes. So I'm gonna go about and draw, and I hope that I'm making myself clear that you have this, let's say, a support system, and what I'm doing is drawing a rectangular surface, which is the same inert polymeric support system that we are talking about here, right? So what this support system is, any kind of material. And you can imagine that this could be silicon. Silicon is usually is inert. You can also go be any kind of other metal It could be, any kind of fiber material or any kind of material which does not react with the fermentation process. So you have a surface, and what you're going to do is have the enzyme system, which is actually uh, there absorbed on that surface, right? So you have this system which is completely coated with the enzyme. And what you're going to do is going to insert this support system inside the vessel and the tank in which fermentation is going on, or what kind of enzyme that you want to produce, right? So this kind of system is an immobilized enzyme system. And what you're going to do once you lift up this support system, you're lifting out the enzymes, and it is much easier because the extraction of the enzyme is easier, and you can reuse the same adsorbed, immobilized enzyme back in any other reactants as well, in any other kind of fermentation tank or in any other form of reaction that you're performing. So immobilized enzyme concept has actually improved the entire extraction procedure. Also, the product does not become contaminated with the enzyme, of course, because enzyme is not dissolved inside the fermentation media, but in fact, the enzyme is there supported on this any kind of inert polymeric matrix. And application of immobilized biological catalyst includes the production of amino acids, organic acids, sugar syrups, name it, any procedure which involves the use of enzyme, they would prefer to use immobilized enzyme system. Okay, so now let's look into industrial chemicals and fuels. Industrial feedstock chemicals supplied through fermentation includes alcohol solvents such as acetone and acetic acid, and raw materials for the production of plastics. And some of these fermentation products have an application in food manufacturing as well, right? So whatever kind of chemical that is produced here can serve as a purpose of fuel in several different other industries, right? So fossil fuels, especially oil, has become exhaustive, like so now there is this new surge, and that surge is using biological fuel generation, which would actually cut down the requirement of relying on fossil fuel, and it is more environmental friendly as well, like bioethanol, like methanol, and all these kind of fuels which are prepared from natural sources like crops, like natural vegetation, agricultural and domestic organic waste is actually provided, and then there are bacteria which utilize these wastes, right? Whether it's vegetation, whether it's domestic organic waste, whether it is agriculture coming from industry, whether it is plants, whatever it is, you provide this to bacteria, and bacteria are going to assimilate them, use them as an energy source, and what is going to be a resultant product depends upon the kind of bacteria you have utilized, but you would get potential fuels. And these fuels have a lot of economical importance, of course, because it is definitely going to cut down our reliance on fossil fuels. So if it's going to cut this down, we're going to get all other natural sources of fuels. We're going to get hydrogen, we can get methanol, we can get methane gas, which is famously known as biogas, and we can get all other derivatives of alcohol, and they all have uses in different industries as an energy fuel. So if it has this property, then you can see that this is also a source of energy, right? So we've looked into many different fermentation forms, and all of these are basically